Alright, we're going to start on Nightly Review 23. And the first one we're going to do is Monday. Write an equivalent fraction. So, we have 5/6 and we have 3/4. If you remember from last week's Nightly Review, to find an equivalent fraction, all you're doing is multiplying the top and the bottom numbers of your fraction by the same number, and that fraction you create when you do that is going to be equal to this one. So I'm going to multiply this one by 3 to get an equivalent fraction. 5 times 3 is 15. 6 times 3 is 18. I've created an equivalent fraction for 5/6. You can use any number you want. You can multiply by 2, by 5, by 10. I would go with whatever's easier. So I'll let you do this one on your own since I showed you how to do this one. Number 2 says find the sum. So we have 637,391 plus 372,888. We know how to add. 8 plus 1 is 9. 9 plus 8 is 17. Carry the 1. 3 plus 1 is 4. 7 plus 2 is 9. 7 plus 3 is 10. Carry the 1. 6 plus 3 plus 1 is 10. So you get 1,009,479. Number 3 on Monday says Kathy is baking cakes. If each cake requires 1/12 a teaspoon of vanilla and she has 9/12 of a teaspoon, how many cakes can she make? So we're dividing fractions. So it takes 1/12 for her cake and she has 9/12. So what are you going to split up? How much it takes to make one or how much she has total? You're going to split up how much she has total. So 9/12 divided by 1/12. Now I'm going to go ahead and do KFC, but if you look, our denominators are the same. So this is pretty easy to actually figure out how many she's going to have. But let's go ahead and KFC it. K means we keep, F means we flip division to multiplication, and C means we change, so 12 on top, 1 on the bottom. My 12s cancel out because they're both 12, and you multiply across. 9 times 1 is 9. 1 times 1 is 1. You wouldn't leave it over 1, so she can make 9 cakes. Again, like I said, since they have those common denominators, that should be pretty simple to figure out. Alright, number 4 is a long division problem, and I know how much you love those long division problems. We have 21 outside and 3,479 on the inside. So we have to figure out how many times 21 goes into these numbers. Now, I know the multiplication chart, no, does it? Does the multiplication chart go up to 21 in the agenda? No, I think it stops at 20 or 16 or something like that. So we're going to have to do some work on the side. So first things first, can 21 go into 3? No, it cannot, because 3 is smaller than 21. But can it go into 34? It can. I know it's only going to go in it one time, because if I were to do this times 2 or do 21 plus 21, that's going to be 42, and 42 is going to be too big. So it's only going to go into it one time. 1 times 21 is 21. And then we subtract. 4 minus 1 is 3. 3 minus 2 is 1. Then we bring down our 7. Now we're going to have to do some multiplication on the side to figure out how close we can get to 137 when we multiply by 21. So I'm going to try 5 first. 5 times 1 is 5. 5 times 2 is 10. So that's 105. We could probably get closer. So let's try 21 times 6. 6 times 1 is 6. 6 times 2 is 12. 126. If we add 21 to this, we're going to get past 137. So I know it's only going to go into it 6 times. 6 times 21, we said was 126. Now we'll subtract. 7 minus 6 is 1. 3 minus 2 is 1. We bring down the 19. or the 9 to make 119. Well, I have 105 for 5 and 126 for 6, so I know the closest I'm going to be able to get is 5 times. So I'm going to put a 5 above my 9. 5 times 21, we said, is 105. Let's subtract. 9 minus 5 is 4. 1 minus 0 is 1. But now we're out of numbers to bring down, and we still have a remainder. So we need to bring down a 0. But before we do that, we add a decimal on the inside and outside. Then we bring down the 0. How close can we get to 140? Well, 6 times is 126, so let's try one more time. Let's try 21 times 7. 7 times 1 is 7. 7 times 2 is 14. We get 147, so it's too big. So we're only going to be able to go into it 6 times. 21 times 6 is 126. You can't take away 6 from 0, so we borrow. 10 minus 6 is 4. 3 minus 2 is 1. We bring down a 0. Well, we just did the 140, so we know it only goes into it 6 times, which means this is going to keep repeating forever and ever and ever, because once I bring this 126 down and I do my subtraction, I'm going to get 14 again and have to bring down a 0. So we'll just leave it at 165.66 repeating. Remember, we draw that line over the 66s to show that it's repeating forever and ever and ever. All right, number 5 on Monday. Find the sum. So it's decimals, so we need to make sure our decimals are lined up. Luckily, each number has the same amount of numbers in it after the decimal, so that's nice and easy to line up. And now we add. 0 plus 9 is 9. 6 plus 3 is 9. 5 plus 3 is 8. Bring down the decimal. 5 plus 3 is 8. 8 plus 5 is 13. We get 138.899, or 138 and 899 thousandths. Number 6 is the difference. So it's subtraction with decimals, and again, each one has the same amount of numbers after the decimal, so those are nice and easy to line up. And now we subtract. You cannot take away 9 from 0, so I have to borrow from the 4 and make it a 3. 10 minus 9 is 1. I can't take 7 away from 3, so I have to borrow from the 4, make it a 3. My other 3 becomes a 13. 13 minus 7 is 6. I cannot take 8 away from 3, so I need to borrow from the 5. 5 becomes a 4. 3 becomes a 13. 13 minus 8 is 5. Bring down the decimal. 4 minus 3 is 1, and 6 minus 4 is 2. So we get 21.561, or 21 and 561 thousandths. All right, number 7 is the LCM. Remember, LCM stands for least common multiple. And multiples are those answers to different multiplication problems. So they want us to find the LCM of 2 and 5. So let's just go through our times tables. 2 times 1 is 2. 2 times 2 is 4. 2 times 3 is 6. 2 times 4 is 8. 2 times 5 is 10. Let's go through our 5 times tables. 5 times 1 is 5. 5 times 2 is 10. 5 times 3 is 15. 5 times 4 is 20. 5 times 5 is 25. Now we look for what they have in common. We see they have the 10 in common. And we're looking for the least common multiple, so the smallest number, and that would be the smallest number. So the LCM of 2 and 5 is 10. Make sure you're writing all of this down when you do it. Do not just put 10 in the blank. We will mark it wrong. Show your work. Alright. Number 8 is the GCF, which is similar to least common multiple, but in GCF we're looking for factors, and factors are the numbers we use when we multiply. Least common multiple was looking for the answers or the products to multiplication. GCF is looking for the factors. So we need the greatest common factor between 54 and 32. So let's go through 54 first. So I already know that 1 and 54 is going to give me 54 if I multiply those together. I know 54 is an even number, which means 2 is going to go into it. But how many times? Well, 2 goes into 5 2 times. 2 goes into 14 7 times. So it's going to go into it 27 times. So 2 and 27. Will 3 go into 54? It will, because I'm going to use my trick of what I know. If I add my two numbers together and it's a multiple of 3, I know 3 will go into it. 5 plus 4 is 9. And 3 does go into 9, so that means 3 is going to be able to go into 54. How many times? Let's find out. 3 goes into 5 one time. 3 goes into 24 8 times. So 3 times 18 will give us 54. Will 4 go into it? Let's find out. So we have 54 divided by 4. 4 goes into 5 one time. We subtract. 4 does not go into 14 at all. So that means 4 does not go into 54. 5 will not go into 54 because it doesn't end in a 0 or 5. Does 6 go into 54? It does. If you remember your multiplication, 6 times 9 gives you 54. Does 7 go into 54? It does not. Does 8? It does not. Now we're back to 9, which means we are done with 54. Only 1, 2, 3, 6, 9, 18, 27, and 54 will go into 54. Now we're at 32. We know that 1 and 32 will go into 32. 32 is an even number, so we know 2 is going to go into it. How many times? 2 goes into 3 one time. We subtract and bring down our 2. 2 goes into 12 6 times. So 2 times 16 will give us 32. Will 3 go into 32? It does not. Will 4? Yes, it will. 4 times 8 gives me 32. Will 5 go into 32? It will not, because it doesn't end in a 5 or 0. Does 6 go into 32? It does not. Does 7? It does not. Now we're back to 8, which means we're done. Now we need to find those numbers they have in common. They both have a 1. They both have a 2. And that's it. I don't see any other matches, which means the greatest common factor of 54 and 32 would be 2. And the last one, I'm not even going to write this one down. Look at number 9. Fill in the blanks. For every blank squares, there are blank circles. All you have to do is count. For every 3 squares, there are 2 circles. That's it. That is the Monday column. Alright, we're on to the Tuesday column, and the first one is our order of operations. So make sure you write this down on paper, because there's definitely not enough room to do this on your nightly review. You could always use the back for your work, but eventually your back is going to be taken, so you're going to need paper. There's not any way possible to fit everything you need on here. Alright, so before we start, let's do our order of operations. We know we go with parentheses, exponents, multiply or divide, add or subtract. Parentheses first, which we have. 50 plus 2 is, oh, it's not plus 2 though, it's divided by 2. I just saw. Yep, 50 divided by 2. So, let's go ahead and do 50 divided by 2. 2 goes into 5 2 times. 2 times 2 is 4. Subtract, bring down the 0, 2 goes into 10 5 times, 5 times 2 is 10, subtract, we get 0. So 50 divided by 2 is 25. Then we bring the rest down. We're done with parentheses, so we'll move on to exponents. We have 5 cubed over here, which means we need to do 5 times 5 times 5. 5 times 5 is 25. 25 times 5, we might need to do on the side real quick. 5 times 5 is 25. Carry the 2. 5 times 2 is 10, plus 2 more is 12. So we get 125, and we bring the rest down. Now I think of my 25 plus 125 as like quarters, so I know if I add one more quarter to this, I'm just going to get 150 minus 5. If I take away 5 from 150, I'll end with 145. So that was the first one on Tuesday. Number 2 on Tuesday is subtraction. We need to find the difference. This is easy stuff. We just have to make sure we remember to borrow when we need to. That seems to be the biggest mistake. We cannot take away 7 from 5, so we need to borrow. We can't borrow from a 0, so we need to borrow from the 8. The 8 becomes a 7. The 0 becomes a 10, but we need to borrow from the 10, so the 10 becomes a 9, and our 5 becomes a 15. 15 minus 7 is 8. 9 minus 6 is 3. 7 minus 6 is 1. 6 minus 6 is 0. 5 minus 3 is 2. And 2 minus 1 is 1. We get 120,138. Number 3 is another lovely dividing fractions, which means we're going to be using KFC. K means to keep, so we keep 8/11ths the way it is. F means to flip, divide comes to multiply. C means to change, so 5 on top, 3 on the bottom, multiply across. 8 times 5 is 40. 11 times 3 is 33. Now we can't leave it like this. We need to turn it into a mixed fraction. Well, I know 33 is only going to be able to go into 40 one time. 40 minus 33 is 7. So I'm going to take my big number 1. I have 7 left over as my remainder, and my bottom number stays the same. So 1 and 7/33s, or 7/33. Done with that one. Number 4 is some more long division. We have 3,784 divided by 18. So first things first, how many times does 18 go into 3? It does not, but it will go into 37. Let's see, 18 times 2 is, 8 times 2 is 16, carry the 1, 2 times 1 is 2, plus 1 is 3. 36, 37, that's as close as we're getting. So 2 on top, 2 times 18 is 36, subtract, we get 1, we bring down the 8. Well, 18 will go into 18 exactly one time. 1 times 18 is 18. When we subtract, we're left with 0, and we bring down a 4. 18 does not go into 4, but we can't leave it like this, so we need to add a decimal to the inside and outside, bring down a 0. I already know 18 times 2 is 36, so that's as close as I'm going to get to 40, so I'll put a 2 on top. 2 times 18 is 36. 40 minus 36 is 4. This is similar to the one we did in the Monday column. If we bring down another 0, we're just going to get 40 again, and it'll go into it 2 times, And then 40 minus 36 is going to be 4 again, and the cycle is going to keep repeating forever and ever. So we're just going to draw that repeating line above our 0.22. Our answer will be 210 and 22 repeating. Number 5 is multiplication, and it's multiplication with decimals. So with multiplication, I always remember ignore the decimal until the end. We're just going to pretend it doesn't exist. 8 times 7 is 56. Carry the 5. 8 times 0 is 0. Plus 5 is 5. 8 times 3 is 24. 4 down low. Carry the 2. 8 times 4 is 32. Plus 2 more is 34. So I cross off my old. I put a 0 placeholder. Moving on to my 1. 1 times 7 is 7. 1 times 0 is 0. 1 times 3 is 3. 1 times 4 is 4. Let's add these up. 6 plus 0 is 6. 7 plus 5 is 12. 4 plus 1 is 5. 4 plus 3 is 7. 3 plus 4 is 7. Now with decimals, we count how many numbers were behind the decimals originally. So here's our decimals. We had 0, 7, and 8 behind our decimals. So that was 3 numbers total. So we're going to move our decimal 3 places in. So your final answer will be 77 and 526 thousandths. Number 6 is another dividing one. It says find the quotient. So that smaller number is going to go on the outside since it was the second number. And 23 and 7/10 will go on the inside. Now with decimals, when we're dividing, we like to move them out of our divisor. So to move them out of the divisor, if we move it here to make it an 18, we move it there to make it an 18, or to make it equal, and we move it up top as well. So now 18 can go into 23 how many times? Well, we just did 18 earlier, and when we did 18 times 2, we got 36. So we know it can't go into it 2 times, only 1. So we're going to do 23 minus 18. We get 5. Bring down the 7. Well, let's try 18 times 3 next to see how close we can get to 57. 3 times 8 is 24. Carry the 2. 3 times 1 is 3, plus 2 more is 5. So that's as close as we'll get. So 3 times 18 we said is 54. 7 minus 4 is 3. Bring down the 0. Well, 18 times 2 is 36, so we know we're not going to be able to get to 32 times, only 1 time. 1 times 18 is 18, and now we subtract. We get 12. We don't have to put a decimal because we already have a decimal up here, so we can just bring down another 0. How close will we get to 120? Let's try 18 times 6. 6 times 8 is 48. 6 times 1 is 6, plus 4 is 10. So there's 108. Let's try times 7. 7 times 8 is 56. Carry the 5. 7 times 1 is 7, plus 5 is 12. So that's too big. So it's going to go into it 6 times. 6 times 18 we said is 108. So now we'll subtract. We get 12. This is just like what we had earlier, and then the one in the Monday column as well. If we bring down another 0, it's only going to get the closest 6 times, so we're going to have our 6's repeating over and over and over again. So we can just put that repeating line over our 6's. We get 13 and 166 thousandths. Alright, the next one is number 7. It says use the distributive property to express 14 plus 63. Well, this is when we look at these two numbers and think about what are these multiples of? What factors go into these numbers? I know 7 can go into both of these numbers, so I'm going to put a 7 on the outside of my parentheses. 7 goes into 14 2 times. 7 goes into 63 9 times. So this is the distributive property. If I were to distribute this 7, I would get the same thing up there. So 7 parentheses 2 plus 9 is how we use the distributive property. Alright, number 8. Emma says the GCF of 16 and 12 is 48. Her friend says the answer is 4. Who is right? Well, remember, GCF, it stands for greatest common factor, and factors are what we use to multiply. So let's find our factors of 16 and 12. So I know 1 times 16 gives me 16. I know 2 times 8 gives me 16. 3 does not go into 16, but I know 4 times 4 is 16. We're done. 12, we get 1 and 12. 2 times 6. And 3 times 4. And that's it. We have a 1, a 2, and a 4 in common. So who's right? Grace. Because she actually found the factors, and what Emma did was probably the LCM, where you write the multiples out. So Grace, because Emma did not use factors. Alright, the last one, it says write the ratio of squares to circles in 3 different ways. So it has the semicolons, it has the word to, and it has the fraction bar. And there are 4 squares and 3 circles. So squares to ratio, 4 to 3, 4 to 3, 4 to 3. Alright, let's move on to the Wednesday column of Nightly Review 23. Sorry about that, this cord is in my way. Alright, so find an equivalent fraction. We've already done that on Monday. That was when we had to pick a number to multiply the top and the bottom by to get our equivalent fraction. So if you're not sure how to do this, go back to Monday, because I'm not going to do this again with you. You guys should just pick a number. Whatever you do to the top, do to the bottom, you'll have an equivalent fraction. Number 2 is find the product. So we have 6,372 times 75. So let's just take it one place value at a time. 5 times 2 is 10, carry the 1. 5 times 7 is 35, plus 1 is 36. 5 times 3 is 15, plus 3 more is 18, carry the 1. 5 times 6 is 30, plus 1 more, 31. Cross off the old, put your 0 placeholder. Let's move on to the 7. 7 times 2 is 14. 7 times 7 is 49, plus 1 is 50. 7 times 3 is 21, plus 5 is 26. 7 times 6 is 42, plus 2 more is 44. Now we add. 0 plus 0 is 0. 6 plus 4 is 10, carry the 1. 8 plus 0 plus 1 is 9. 6 plus 1 is 7. 4 plus 3 is 7. 4 plus nothing is 4. You get 477,900. For number 3, we're doing some dividing of fractions. So it says a strip of paper is 9/10 of an inch long. You need to cut that paper into 3/12 inch pieces. So what are we dividing up? The long strip of paper or what we want in the end? We're dividing up the big strip of paper. So let's use KFC. K means to keep, F means flip division to multiplication, C means to change, 12 on top, 3 on the bottom. Now I'm going to do this the easier way for me, which I know 10 and 12 have a number in common. 2 goes into both of them. 2 goes into 10 5 times, 2 goes into 12 6 times. And I know 3 and 9 have numbers in common. 3 goes into 3 1 time, and 3 goes into 9 3 times. This makes my multiplying across easier than doing 9 times 12 and 10 times 3. 3 times 6 is 18. 5 times 1 is 5. Now we need to turn this into a mixed number. 5 goes into 18 3 times. 3 times 5 is 15. I'm left with a remainder of 3. So that means my big number for my mixed fraction will be a 3 since it goes into it 3 times. This is my remaining on top, and my bottom number stays the same. So 3 3/5. That's how many pieces that she'll be able to cut. Okay. Number 4 is another long division. Woohoo! I hope you guys are long division masters by the time I'm through with you, because there's so many of them. Alright, we have to figure out how many times 17 goes into this number. So, how many times does 17 go into 6? It doesn't, because 6 is too small. But how many times does 17 go into 66? Let's guess and check. Let's try 17 times 3. 3 times 7 is 21. Carry the 2. 3 times 1 is 3, plus 2 more is 5. So we have 51. Now I'm thinking 17 times 4 is going to be too big, but I'm going to do it anyway. 4 times 7 is 28. Carry the 2. 4 times 1 is 4, plus 2 more is 6. Yeah, 68 is bigger than 66, so we can't use 4, but it can go into it 3 times. 3 times 17 is 51. We'll subtract. 6 minus 1 is 5. 6 minus 5 is 1. And we'll bring down the 2. Now we need to see how many times does 17 go into 152. Let's do some more guess and check. Let's try 17 times 6. 6 times 7 is 42. Carry the 4. 6 times 1 is 6, plus 4 more is 10. So we can go pretty big. Let's try times 8. 8 times 7 is 56. Carry the 5. 8 times 1 is 8, plus 5 is 13. Let's try one more. 17 times 9. 9 times 7 is 63. Carry the 6. 9 times 1 is 9, plus 6 is 15. So 153 is just one too big for this. So we're going to go with 17 times 8. So 8 on top. 8 times 17 we said is 136. Let's subtract. 12 minus 6 is 6. 4 minus 3 is 1. Bring down the 3. Well, we know as close as it's going to get is 9, so we'll put our 9 on top. 9 times 17 is 153. Now we'll subtract. 3 minus 3 is 0. 6 minus 5 is 1. I can't bring down another 0 until I add a decimal, and if I put 1 on the inside, we got to put 1 on top. Now we'll bring down the 0. Well, here I see 4 times is 68, 6 times is 102. I'm guessing 5 is probably what we're going to have to use, so let's do 17 times 5. 5 times 7 is 35. Carry the 3. 5 times 1 is 5, plus 3 more is 8. Well, if 17 times 6 is 102, that's going to be too much, so we have to go with 85. So we'll put a 5 on top. 5 times 17 we said is 85. And now we subtract, borrow. We get 15. Bring down a 0. How close can we get to 150? That would be 8 times. 8 times 17 is 136. We'll subtract. 10 minus 6 is 4. 4 minus 3 is 1. We'll bring down a, I'm running out of room, Miss Norris. Bring down a 0. How close do we get to 140? That would be 8 times. We get 136. 10 minus 6 is 4. Bring down a 0. How many times will 17 go into 40? The closest we're going to be able to get is times 2. 17 times 2 is 14. Carry the 1. We get 34. So 2 times. We're left with 6. And I'm going to stop here because we're not going to keep going forever and ever. You get 389.5882. And just know we can keep going, but I'm sure your teacher wants you to stop after the 3rd decimal, and we went to 4. So we're going to keep it at that. 389.5882. Number 5 is to find the sum and its decimals, but every single one has the same amount of numbers after the decimal, so there's no issue with lining them up correctly. 7 plus 4 is 11, carry the 1. 8 plus 1 plus 3 is 12, carry the 1. 8 plus 1 plus 2 is 11, carry the 1, bring down your decimal. 8 plus 1 plus 2 is 11, carry the 1. 5 plus 1 plus 9 is 15. We get 151 and 121 thousandths. Number 6 is to find the difference. Again, each number has the same amount of numbers after the decimal, so that makes lining it up easier for us. 7 minus 2 is 5. 7 minus 3 is 4. 7 minus 4 is 3, decimal. 5 minus 2 is 3. 8 minus 4 is 4. That's what we're left with. You know, Miss Norris's office is just a happening place. The door's always knocking, so we'll keep on going now. Number 7 is what is the least common multiple of 3 and 4? So LCM, least common multiple. Multiples are our answers or our products in multiplication. So let's list out our multiplication times tables for 3 and 4. 3 times 1 is 3. 3 times 2 is 6. 3 times 3 is 9. 3 times 4 is 12. 3 times 5 is 15. Let's do 4 now. 4 times 1 is 4. 4 times 2 is 8. 4 times 3 is 12. 4 times 4 is 16. And 4 times 5 is 20. Now we need to find what they have in common. I see a 12 in common, and that's the only one I see so far, which is fine because it's the least common multiple. So the least common multiple between 3 and 4 is 12. Again, make sure you have this all written down when you're doing it, though. You can't just write 12. Number 8 is the greatest common factor, which is different than LCM. LCM are our answers to multiplication problems, whereas greatest common factors are what we use to get to the answer. So we need to find it for 28 and 72. So we'll start with 28. We know 1 times 28 is going to give us 28. 28's an even number, which means 2 is going to go into it, but how many times? Let's see. 2 goes into 2 1 time. 2 goes into 8 4 times. So 2 times 14 gives me 28. 3 does not go into 28 if you think about your facts. The closest it can get is 27. 4 does go into 28 though. 4 times 7 is 28. 5 will not go into 28 because it doesn't end in a 0 or a 5. And 6 does not go into 28. Now we're back at 7, which we already have, so we're done with 28. Now we need to do 72. We already know 1 times 72 is 72. Now we need to figure out how many times does 2 go into 72, because it will, since it's an even number. 2 goes into 7 3 times. 3 times 2 is 6. Subtract, bring down. 2 goes into 12 6 times. So 2 times 36 gives us 72. Now 3. How many times does 3 go into 72? Let's see if it does. 3 goes into 7 2 times. 2 times 3 is 6. Subtract, bring down. 3 goes into 12 4 times. So it does go into 72. 3 times 24 gives me 72. Now what about 4? Does 4 go into 72? Let's see. 4 goes into 7 only 1 time. 7 minus 4 is 3. Bring down the 2. 4 goes into 32 8 times. So 4 times 18 gives us 72. 5 will not go into 72 because 72 does not end in 0 or 5. 6 goes into 72 6 times 12. 7 does not go into 72. 8 goes into 72 8 times 9. And since we already did 9 just now, that means we're done. So what numbers do they have in common? They both have a 1. They both have a 2. They both have 4. And that's all I see. So the greatest common factor, the greatest factor they have in common is 4. Alright, the last one in the Wednesday column is apples and oranges. Alright, so there are 6 apples. Those are my apples. These are my oranges. So the apples have stems. Okay. Write the ratio of apples to oranges in simplest form. So simplest form. So first off, we have 1, 2, 3, 4, 5, 6 apples to 2 oranges. This is not simplest form though. I know 2 can go into 2 and 6, so we're going to divide to put it in the simplest form. 2 goes into 6 3 times. 2 goes into 2 1 time. That's my simplest form. You could also do this by making sure you split your apples evenly with your oranges. Like here's 3 apples and an orange. There's 3 apples and an orange. You can circle it like that too to get 3 to 1. Alright, we're on the Thursday column, almost done. And the first one on Thursday is order of operations. We have 21 divided by 7 plus 6 plus 3 cubed. I know my order of operations is parentheses, exponents, multiply, divide, add, subtract. Parentheses first. Right here we have 21 divided by 7. Well, 7 times what number gives me 21? That would be 3. Bring down the rest. We're done with parentheses. We're now at exponents. I have 3 to the 3rd power, or 3 cubed, which means I need to do 3 times 3 times 3. 3 times 3 is 9. 9 times 3 is 27. Bring the rest down. Now we see there is no multiply divide, so we're at add subtract, and we just do it in order. 3 plus 6 is 9. 9 plus 27 is 36. Number 2 on Thursday is long division. Again, don't we love our long division? If you go in your agenda, there is a multiplication chart that goes all the way to 15. But I'm still going to be, guessing and checking over here. So whichever way you prefer. So first things first, I need to see how many times 15 goes into 4. It does not. But how many times does 15 go into 43? Let's guess and check. I'm going to do 15 times 2 and 15 times 3. 2 times 5 is 10, carry the 1. 2 times 1 is 2, plus 1 is 3. 3 times 5 is 15, carry the 1. 3 times 1 is 3, plus 1 is 4. So 45 is too big, so we're going to have to go 2 times and 30. 3 minus 0 is 3. 4 minus 3 is 1. Bring down the 7. Let's do some guessing and checking over here. 15 times, we'll go with 7. 7 times 5 is 35, carry the 3. 7 times 1 is 7, plus 3 more is 10. We could probably get closer. Let's try 8. 8 times 5 is 40, carry the 4. 8 times 1 is 8, plus 4 more is 12, 120. We'll even try one more. 15 times 9. 9 times 5 is 45, carry the 4. 9 times 1 is 9, plus 4 is 13. So that's the closest we can get, is 135. So 9 times, subtract, 7 minus 5 is 2, bring down the 8. We saw that 15 times 2 is 30, which is too big, so it means it's only going into it one time. 1 times 15 is 15. Subtract. 8 minus 5 is 3. 2 minus 1 is 1. We can't bring down a 0 yet because we need to add our decimals in the inside and the outside, and we'll bring down a 0. The closest we can get to 130 will be 8 times. So 8 on top. 8 times 15 we said is 120. When we subtract, we get 10. Bring down a 0. Well, 15 times 7 is 105, so it's going to go into it one less time. So let's do 15 times 6 to find out. 6 times 5 is 30, carry the 3. 6 times 1 is 6, plus 3 more is 9. So 6 on top, 90 down low, subtract, we'll get 10, which means we're going to keep repeating again. Because if we bring down a 0, we know 15, the closest we can get to 100 is 6 times, so we'll put the 6 back up here, and we'll bring the 90 down, and we'll keep getting 10 forever and ever and ever, which means we can put the repeating symbol above the 6's. It's 291 and 866 thousandths repeating. Okay. Number 3 is some KFC. We have 4/5 divided by 3/7. Keep, flip, change time. K means we keep, F means flip, C means change the order of the numbers, and multiply across. 4 times 7 is 28. 5 times 3 is 15. Well, now we need to put this into a mixed number. So we have to see how many times 15 can go into 28. I'm going to grab that work that we just did over here because this is going to help me know how many times 15 goes into 28. The closest we can get to 28 would only be one time because 30 is too big. When I subtract, I'm left with 13. So I'm going to have a 1, 13 is left over, and my bottom number stays the same. So we get 1 and 13/15. All right, number 4 is some more long division, but we're dividing by 12, and we should know our 12s. If you don't, pull out a multiplication chart right now so you can follow along with me, because I'm not going to write the guesses and checks over here since 12s are something we should know. How close can we get to 54? How many times can 12 go into 54? That would be 4 times. 12 times 4 is 48. We'll subtract. We get 6, and we bring down the 3. How many times can 12 go into 63? 5 times. 5 times 12 is 60. 63 minus 60 is 3. Bring down the 4. Well, I know 12 times 3 is 36, so 3 is not going to work, so it has to be 2. 2 times 12 is 24. We're left with 10. So we need to add a decimal on the inside, add a decimal on the top, bring down a 0. When it comes to 100, I know 12 times 9 is 108, so that means it's only going to go into it 8 times. 8 times 12 is 96. Subtract, bring down a 0. 12 goes, well, we saw earlier 12 times 4 is 48, so it's only going to go into it 3 times. 3 times 12 is 36. When we subtract, we're left with 4 again, which means this one is going to keep repeating. When we bring down another 0, we know it only goes into it 3 times. We'll bring down the 36. We'll be left with 4 again. So these 3's are going to repeat forever. So my answer is 452 and 8 33 thousandths. All right, now we are on, let's see, 1, 2, 3, 4, 5 on Thursday. We have multiplication, 31.24 times 3.9, and just like all the other times we're multiplying decimals, wait to do the decimal until the end. Okay. So let's multiply how we know how to. 9 times 4 is 36. Carry the 3. 9 times 2 is 18. Plus 3 is 21. Carry the 2. 9 times 1 is 9. Plus 2 more is 11. Carry the 1. 9 times 3 is 27. Plus 1 more is 28. Cross off the old. Put your placeholder 0, and we'll move on to the 3. 3 times 4 is 12. Carry the 1. 3 times 2 is 6. Plus 1 is 7. 3 times 1 is 3. And 3 times 3 is 9. Let's add together. 6 and 0 is 6. 1 and 2 is 3. 1 and 7 is 8. 8 and 3 is 11. Carry the 1. 9, 2, and 1 is 12. Now let's count how many numbers were behind decimal places. We had the 9, the 4, and the 2. 3 total numbers, so we're going to move our decimal 3 places in. So we get 121.836. The next one is another long division one, the ones we all know and love. We have 24.31 divided by 2.6. So first things first, when we have a decimal in our divisor, we like to move it out so we can make it a 26. Whatever we do out here, we do it in here too, and then we pop the decimal up on top. Now it's time to do 26. How many times does 26 go into 2? It doesn't. How many times does it go into 24? It doesn't. So we're looking for 243. So that's a pretty big number, so I'm going to start off with 7 right away and see how close we can get. 7 times 6 is 42, carry the 4. 7 times 2 is 14, plus 4 is 18. So we could probably get up even more. Let's try times 9. 9 times 6 is 54, carry the 5. 9 times 2 is 18, plus 5 is 23. So that's probably as close as we're going to get, is at 9, so we'll put the 9 on top. 9 times 26 we said is 234, and then we'll subtract. We need to borrow. We get 9, bring down the 1. So now we have to see how close 26 can get to 91. Let's try 26 times 3. 3 times 6 is 18, carry the 1. 3 times 2 is 6 plus 1 is 9. So 98. Or whoa, 6 plus 1 is not 9. What am I saying? 7. It's Friday. Give me a break. Alright, so 78. Let's try times 4. 4 times 6 is 24, carry the 2. 4 times 2 is 8, plus 2 more is 10. So too big. So we're going to go with 3. Three times 26 we said is 78. Subtract. We get 13. And since we already have our decimal in place, we can bring down a 0. So how close can we get to 130? Let's try times 5. 5 times 6 is 30, carry the 3. 5 times 2 is 10, plus 3 more is 13. Look at that, exact. Which means we got to 0. So our answer is 9 35/100ths. Okay, we're on number 7, which is a word problem. It says the red string of holiday lights blinks 1 time every 3 seconds. So red, it takes 3 seconds. While a string of blue lights blinks every 4 seconds. How many times will both sets of lights blink at the same time in 1 minute? So 1 minute is 60 seconds. So we're not going to go any further than 60 seconds. So let's go ahead and list out our multiples for both of these and see how many they have in common. So it's like doing the least common multiple, only we're going to go until we get close to 60, because once we get to 60, that's when these lights will go off. They only want to know in 60 seconds. So 3 times 1 is 3. 3 times 2 is 6. 3 times 3 is 9. 3 times 4 is 12. 3 times 5 is 15. 3 times 6 is 18. 3 times 7 is 21. 3 times 8 is 24. 3 times 9 is 27. 3 times 10 is 30. 3 times 11 is 33. 3 times, I'm going to run out of room, I'm realizing, 36. Then 37, 38, 39. 40, 41, 42. I'm just going to trick the system. There we go, 42. 43, 44, 45. 46, 47, 48. 49, 50, 51. 52, 53, 54. 55, 56, 57. 58, 59, 60. And like I said, we stop at 60 because we're only finding a minute. Let's list out 4 now. 4 times 1 is 4. 4 times 2 is 8. 4 times 3 is 12. 4 times 4 is 16. 4 times 5 is 20. 4 times 6 is 24. 4 times 7 is 28. 4 times 8 is 32. 4 times 9 is 36. 4 times 10 is 40. 4 times 11 is 44. 4 times 12 is 48. And then if you don't want to keep doing your times tables, all we have to do is just keep counting up. So 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60. So now we're at 60. So let's see how many numbers they have in common, because that'll be how many times they blink at the same time. So I'm going to grab a highlighter for that. Excuse my reach. All right. I see they both have 12s. They both have 24s. They both have 36s. They both have 60s. And they both have 48s. I skipped 48. That's all I see that they have in common. So how many times is that? 1, 2, 3, 4, 5. So the Christmas lights are going to blink 5 times together each minute. 5 times per minute. Alright, let's take a look at the next one. Angie baked 100 cookies and 20 brownies. She wants to split them into equal groups for the bake sale. Each group must have the same number of cookies and brownies with none left over. What is the greatest number of groups she can make? So we have 100 cookies to 20 brownies. In order to figure out how many groups she can make, let's first figure out what our rate would be. How many cookies to how many brownies? Well, I know 20 can go into 100. So we're going to divide these each by 20. 20 goes into 20 one time. 20 goes into 100, well, 20, 40, 60, 80, 100, 5 times. So 5 cookies. So each group is going to have 5 cookies and 1 brownie. Well, what did I just divide by? I just divided by 20. So if I were to multiply these by 20, I would get right back to where I started from with the 100 cookies and 20 brownies. So this means there will be 20 groups that I can make. And the last one is number 9. To make hummingbird nectar, you must use 4 cups of water and 1 cup of sugar. I'm just going to go ahead and write this out already because I'm sure we'll need it. What is the ratio of water to sugar? Well, I just said we probably need this information. So the ratio of water to sugar would be 4 cups of water to 1 cup of sugar. You just finished Nightly Review 23.